This Sharp mini split air conditioner is showing F1 and F2 errors, and I will tell you how to fix them both. So first, let's fix the F1 error from this Sharp air conditioner. Completely remove the front cover of the indoor unit because this is an indoor fault related to the indoor PCB. On the PCB, there is a sensor attached, commonly referred to as the room temperature sensor or ambient temperature sensor. This sensor reads the room's temperature and sends signals to the PCB. If the F1 error occurs, you should inspect this sensor and its connection to the PCB. Now, as you can see, I have removed the PCB from the box. In older systems, or even some current systems, the sensor is typically installed on the evaporator. However, in this particular model, the company has installed it in a different location. This spot here is where the room temperature sensor is installed. If you change its position, it can cause issues because the PCB will not receive accurate readings. This can also result in the F1 error if the sensor is misplaced. Additionally, there's a marking labeled T sensor where two sensors are installed. One, a pipe coil sensor. Second, the room temperature sensor. The yellow wire corresponds to the room temperature sensor. I'll also share its resistance value with you. If this sensor becomes faulty, it can also trigger the F1 error. To resolve this, ensure that the sensor is properly installed in its designated position. This is the top cover of the air conditioner, and in it I will show you something important. On the right side, you can see these three holes. These holes play a crucial role. If they get blocked for any reason, the sensor won't be able to take accurate readings. Similarly, if the sensor itself becomes misplaced from its designated spot, it won't function properly and fail to take accurate readings. This can result in the F1 error or even other potential errors. Therefore, it's essential to ensure these holes remain unblocked and the sensor stays correctly positioned. Now, let's talk about the resistance value of the sensor. For the sensor to work properly, its resistance value must be accurate. You need to know the temperature at which you are testing it. If the resistance value fluctuates, showing inconsistent readings, this indicates that the sensor is faulty. At the moment, the room temperature is 26.7 degrees Celsius, and the multimeter is set to resistance mode. Let's check the resistance of the room temperature sensor. As you can see, it's showing a value of 12.8 kiloohms if the temperature were 25 degrees Celsius. This value would have been slightly higher. Some sensors have their expected resistance value written on them. For example, this one has 15K written on it. However, it is not showing exactly 15K at this temperature, which is still acceptable since the sensor is working fine. Now, when the F2 error appears on the display of a Sharp indoor unit, what should you do? Watch the entire video and you will get all the information you need. Now I've removed the PCB from its cover. Let's take a look. There are two sensors here. The yellow one is the room temperature sensor, and the black one is the pipe coil sensor. The pipe coil sensor monitors the temperature of the evaporator and sends signals to the microcontroller. Let's locate where this sensor is installed. You can see a cover here. When you remove this cover, you'll find the sensor underneath it. I've removed the cover from the evaporator, and now you can see how the microcontroller uses this sensor to sense the evaporator's temperature, determining how much cooling has occurred. If there's insufficient cooling, the unit won't operate properly. Similarly, if the sensor is missing, the microcontroller won't know what the system is doing, which makes this sensor essential. If it becomes faulty, it will also trigger the F1 error. Now, let's talk about testing the pipe coil sensor's resistance. First, ensure the room temperature is stable. Currently, the room temperature is 26.8 degrees Celsius. I'll now test the black pipe coil sensor. As you can see, it's showing a resistance value of 18.51 kiloohms, which means the sensor is functioning correctly. To confirm, test it again. If the value remains consistent without any fluctuations, such as showing one value at one moment and another the next, the sensor is fine. However, if there are fluctuations, the sensor is faulty and needs to be replaced. Once the sensor is replaced, the F2 error will be cleared from the display. If you've replaced the sensor, but the fault still doesn't clear from the display, let me explain what might be causing the issue. I've disconnected the connectors from this PCB. At the connector points, you should measure 5 volts. If these 5 volts are not present, the fault might be within the PCB itself. Here's how the pins are configured on this PCB. Pin 1 is the ground pin. Pin 3 is also a ground pin, and both are common. Pin 2 and pin 4 should have plus 5 volts. When you test pins 2 and 4, you should see 5 volts. If 5 volts are missing, this indicates a PCB issue, and the PCB will need to be repaired. In most cases, however, the fault is caused by the sensor itself. If the sensors are faulty, the error will appear. But if the sensors are working fine and 5 volts are not present, then it's a PCB fault that needs attention. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.